Hello, everyone. I hope everyone is having a good day. We're going to continue our talk about atomic radius. So, we just said that we defined atomic radius as the distance between the nucleus and the valence shell, right? Now let's take a look at the periodic table, and we're going to specifically look at lithium, sodium, and potassium. So we have lithium, which has a electron configuration of 2, 1. We have sodium, which has an electron configuration of 2, 8, 1. And then we have potassium, which has an electron configuration of 2, 8, 8, 1. Obviously, these are all in the ground state, and these are all the atoms. And we can tell that this is going to have the potassium is going to have the largest radius, whereas lithium is going to have the smallest radius, right? And that makes sense because the more shells you have, the larger the radius. And not just any shells, the more occupied shells you have, the larger the radius. Right, and so we can see that potassium has 4 occupied shells. 1, 2, 3, 4, whereas lithium only has 2. And obviously sodium is going to be right in the middle. Now there's another term that we do need to know called Ionic radius. And you're going to find this definition very familiar. The Ionic radius is the distance from the nucleus to the valence shell. Yes, it is identical to atomic radius. The only difference is this is specifically for ions. And really, what we're trying to do is we're comparing the ionic radius to the parent atom's radius. What do I mean by parent atom? Literally, the parent atom is the original atom. And if we look at the reference table, we can see that metals all form the same type of ion, right? All of our metals are all over here to the left of that staircase. And we can see that they all form the same type of ion. So let's look at Mg ion and its parent atom. So the Mg ion, based on the periodic table, is going to be +2. And the Mg atom is simply just Mg. Now, for the electron configuration of the Mg ion, assuming that it is in ground state, it's just that. Whereas the Mg atom is 2, 8, 2. So we can see here that the ion the Mg +2 ion only has 2 occupied shells. So we can conclude that the Mg atom has a greater distance than the Mg ion's radius. So we'll say radius of Mg plus 2 is less than that of the radius of Mg. And in general, we can say that what do we say? In general, we can say that you know what? We'll do something else. Look at the nonmetals. Now, we've said before that metals always gain, but metals tend to lose ions. Nonmetals kind of do both. Nonmetals tend to lose ions, but not always. So sometimes they become negative, sometimes they become positive. But the general rule for any comparison of atom to parent ion is when atoms gain electrons, the radius increases. And when atoms lose electrons, the radius decreases. Right? And that's pretty straightforward. And that is how we compare the radius of an atom to its parent ion. Thank you so much for watching. I hope everyone has a good day. Bye.